Good morning, everybody. Welcome to our webinar, Analyzing Data Orchestration Lineage with Neo4j. This is a webinar set up by NoBI, our partner, and Neo4j. For NoBI, we have Bart Martens, who is the managing partner of NoBI and who will introduce you to the orchestration lineage topic. We have also Matt Casters in the call. Matt is Chief Solution Architect at Neo4j. And before that, he's the father, the developer of Kettle. And he will, of course, introduce you to Apache Hop. And I myself, I'm Herman Roelens. I'm responsible for the Benelux market for Neo4j, and I'm your host for today. My role will be to introduce you to Neo4j and to the technology. I'm not going to go too deep. Let's start the tour. The whole started, in fact, in 2000, where Neo4j started to create the labeled property graph technology. And together with that technology, Cypher. We used at that moment the open source community. And in 2007, Neo4j started with a company. We started our company in Malmö, so we are a Swedish company. But for funding reasons, is our headquarters now based in the Silicon Valley. In the meantime, we have a lot of customers working with our technology. Some of them paying for it, others using our open source version. As you can see, we made some progress already in the market. Here you have some customers that we have at the moment. And very interesting to know is that we are available on-premise, in the cloud with bring your own license. And as of last year and starting of the 1st of January 21, we have our Aura Enterprise who will start, which is a database as a service, completely managed by Neo4j. That we made some progress. Of course, we made some progress. We started in 2000 and mid of 2000 with the big term, big data. And at that moment, we saw clearly that the relational database environment, the red line, wasn't able to follow all that amount of data. And so a lot of new technologies came into the market, which were called the not only SQL, no SQL environment. And the graph database, the green line here, is at this moment the most popular. And it's not us who are saying it, it's DB Engines. It's a website where all database technologies are mentioned and are, I would say, puts one aside the other. And in the graph database space, we are, or DB Engines tells us that we are the #1 in the market, and with quite some different distance towards our conculegas, as I call them in Dutch. Important to note is also that we are a native graph database. And there is a big, big, big difference. How does it come that we are so popular? Very, very simple. We are using the data as people are using data. We are putting on disk, in memory, the data, but also as objects, the relation between the data elements. And that are objects. So you have a pointer system. And if there is and what the computer can do best, of course, is following pointers. And that's exactly where we get our performance from. That the company is working in that way, it should be so. It's not today, it's not always the case, because in the past, those divisions of companies bought best of breed solutions. And those solutions came with their own database environments. And that is the reason why today we have a lot of companies that are working with data silos into their company. And that makes it very, very difficult to work as it should be. As a company is and should work together. It's also the same with building up the knowledge. Think about when you were 6 years and you started to count from 1 to 10, And then from 1 to 20 and 1 to 50, 1 to 100, everything is connected. All those experiences, all those knowledge is connected to each other. And that's how the man is working. It's how people are working. And that's exactly where we have a graph. Let me explain that. Let me show you what the difference is really. Yeah, you know this all. This is a schema, the schema of a relational database. It's working with tables. Yeah, if you see all those connections that are not real connections, that are calculations, joins that have to be done. A better one to know about is, of course, the Excel, the spreadsheet. Yeah, most of the people. Well, what we have done, we have here all the information in that spreadsheet. You have the graphical representation of the data, but look how it is in a graph database. And that is the big difference between relational NoSQL databases based on tables and a graph database labeled property graph database. Every data is connected, but here you see already, simply because it's visualized, yeah, that there is a difference between those 4 elements and all the rest, that there is a difference here, that there is a link between those and not the link here. It gives you a much, much better insight in your data. And that's exactly how we are helping your business value. Yeah, it's harnessing the connections. Yeah, and here you see that we, in several domains, we have transformed the industries. Think about data-driven discovery innovation. Yeah, certainly very, very actual drug discovery, for example, but also, yeah, everything what is fraud and crime and so on and so on. Product and process innovation. We have the hyper personalization. Everybody talks the customer should be the center of. Well, that's exactly where we're talking about. Enhanced decision making. Of course, it's important to see if people are misusing funds, yeah, or that your network is running in the right force, or that the law is followed, yeah. And then, of course, the new world that is coming up is, of course, everything what is artificial intelligence and machine learning, yeah. Think about it. Machine learning feeding your pipelines with data and feeding your pipelines with connected data, with already a form of intelligence into your data. It gives you an enormous difference. If we look at some of the use cases, and here you see a lot of our paying customers, yeah, that are using Neo4j for, yeah, we have real-time recommendations. Of course, you know, the Walmarts and the eBays of the world, yeah, and real-time recommendation can help you, of course, by proposing, if you are interested in one product, by proposing other products that are linked to each other, yeah. But it can also be very helpful in HR environments. Think about connecting the data of your employee and see really that he needs, or that he gets, or he should earn a promotion, or that you are at risk to lose him, because you see it simple in his data if you connect the data. Fraud detection, the same thing, huh? Due to the fact that we are a visualization environment, you see really the things happening. You see fraud rings to customers for 5 years, a complete normal behavior, and suddenly they are asking a very, very big loan. Wouldn't it be interesting for the bank to see that those 2 customers are connected via a telephone number, or in the new composed families via a child? And then it shouldn't be, but it could be that you are talking about fraud. And you see it really. You see those fraud rings in your data. Network IT operations, yeah. HP is one of our customers, yeah. So their network management tools are based on Neo4j, yeah. And it's great to see if one element in your network, and you see it as a graph, of course, that one point in the network is going down, and who is connected to that point, etc., etc. But think a little bit further. It's not only about devices, computers, routers, and so on, but also people. and people that are linked into business processes, and be sure that if something happens, that you can improve things and so on. Master data management. Think about, for example, the NASA. Yeah, they are using us as a knowledge database, and so on and so on. So a lot of business cases, and we are talking within Neo4j as a graph problem. Most of the people don't know that they have a graph problem. What are these people using? Well, we have a platform, and it's not only the database, which is analytical and transactional. No, we are delivering a complete platform. And one of those elements you will hear more about later on, which is an ETL tool, which is Apache Hop, can be part of that environment. Of course, you are going to develop on top of the database. You are connecting your environment with a lot of existing things, and you need the visualization, because that is exactly what is one of the head topics of a graph database. But at the end, you can also do a lot of analytical work with all the algorithms that are part of our technology. That is what the customers are using. And then I want to highlight some very important add-ons and added value. First of all is the visualization, which is very, very important, as I mentioned earlier. Yeah. A second element, we are not here to come and change all your data platforms, etc. No, certainly not. It's not a big bang. What it is think big, start small, and deliver quickly. What we are doing is placing a layer on top of your existing environment and connecting based on the question that you have, connecting the data. Think big, start small, one question, deliver quickly. That's exactly what we can promise you. A last thing, and an important one, is you are with a graph database, you are linking the technical people with the non-technical people. When you're drawing your problem on a whiteboard, well, very, very often becomes the whiteboard model the physical model of a graph environment. And that's exactly what also is very, very nice within a graph environment. So I hope that you have seen that a graph is a big difference with everything what is relational or NoSQL, that we are part of the NoSQL, and that graphs are everywhere. Think about the graph problem. Let us together see how we can move on.
So I want to talk to you guys for about 10 minutes about, Apache Hop and the Neo4j support that we are building inside of it. And so where's Hop coming from? It's a recursive acronym, the Hop Orchestration Platform. And we aim to orchestrate anything related to your data needs, pipelines, workflows, but also, metadata handling, configuration management, lifecycle management, connection management, a lot of that stuff, right? And we want to provide insights into execution lineage, logging, and handle the insane complexity that is the data orchestration world. A lot of servers, a lot of systems working together. And so we provided a tool set in Hop, which, a full integrated development environment on Windows, Apple and Linux systems, and also thin clients. We've designed the UI to work with thin clients to help you design your work on your workstation, and then to run those pipelines, workflows, the stuff that you build locally on a remote server, in a Docker container, and also to do the configuration management using command line tools, so that you can even do these configurations inside Docker containers, etc., etc. So the background of Hop is Kettle 8.2. Kettle originally has always been very community oriented, and as development kind of stalled after the acquisition by Apache. The community actually has kept up developing new plugins, patches, whatever. So at some point, it made sense to start like not just a fork, but a rewrite of Kettle with a new user interface, new metadata backend, simplified toolset, renaming, extra plugins, and so on, and so on. And because it's been really diverting away from the original Kettle idea over the last couple of years, we decided also to join the Apache Software Foundation Incubator Program. And their motto, "Great communities deliver great software," is something that we see. We see a lot of new community members pop up, new users to really join in on the fun, right? And so we are live at hopapache.org, very easy to remember. So we're running completely off of Apache infrastructure right now, and we're working on our first official release. But yeah, you can download continuous builds all the time. And one of the cool things that we're executing and have support for Apache Spark, Flink, and Google Cloud Platform Dataflow, because we support Apache Beam under the covers. And this means that we can now supply data into Neo4j Aura. You can go to neo4j.io and try a server, to start up a server, a Neo4j server. And yeah, since we run on Dataflow, it's easy to start a new Dataflow to stream data from Kafka, for example, into Neo4j. What we're trying to do is not just for Neo4j, but change the perception that data loading is hard, right? A lot of people say, "Oh, yeah, it's hard to data." It's not really hard to load data. It's to do the data orchestration. We want to help you do a better job by making it easier, faster, more transparent, more predictable as well with unit testing, and keep in touch with the latest development in the field. Seems like new development is happening faster and faster. And we want to also support your best practices for development, projects, and project lifecycle environment, so that you can easily set up and switch between development, testing, all the way to production, but also continuous integration environments. Unit testing of complex pipelines, really important. If you spend a lot of time developing data orchestration work, a lot of man hours, it makes sense to not have casual changes mess it up, right? And things like Git version control, and a lot of other things, but those were the three that I wanted to highlight. We want it to be modular in Hop, very small footprint, very fast startup. We're constantly working on improving that. Metadata configuration files and human readable JSON files, one central configuration, stateless servers, so that you can just pop something up, send some work to it without having to spend hours configuring it, standard Docker containers, and so on and so on. But we also have Neo4j plugins, obviously. For the other main concepts in Hop, I'm now going to go over to the Neo4j side, but we have extensive documentation on Apache Hop. It's one of the important things that we're trying to do is really provide you with great documentation. Bart is going to go into some examples of workflows, pipelines, and metadata. And workflow is just a sequential operation sequence of actions. You do one thing and then you evaluate whether or not it ran correctly, and then you do another thing. Pipelines are running in parallel and they're streaming data to each other. For example, you have a Spark pipeline or a Flink or Beam pipeline or even a Hop native pipeline, right? And then metadata is just centrally managed metadata in those JSON files, which represent lots of things like Neo4j connections, database connections, and whatnot. So we have one plugin to execute Cypher for data loading. It's just your Swiss Army knife for Neo4j. You can do everything with that. Neo4j Output, the oldest plugin in the portfolio, allows you to create nodes and relationships without having to know any Cypher. The graph output step goes one step forward further, and it can, you can design like was mentioned earlier, you can develop your requirements in the graph model. And we have actually a tool called Cypher Workbench to do that. It's in beta, which we'll release later. And then you can import that model and map your input columns straight to the graph. And this will this transform will do everything for you. We can also generate bulk load files, which is a very fast way of loading data. You can, billions of nodes and relationships can be loaded in a fairly short amount of time. And so this transform takes care of the pain of generating the proper format. Um, we introduce a new data type in Hop, which is the graph data type, which encapsulates all sorts of nodes, relationships, complex models, and this allows you to tear it apart. You take the nodes and relationships separately and treat them differently, and later we can then do all sorts of operations with that. If you preview that data, it's represented as JSON, and then the Neo4j importer, which allows you to execute bulk loads. For the workflows, we have two new actions. Check if a Neo4j connection is up and running in a world where you're setting up a Docker container. Maybe you might want to wait 5 seconds, but you can also do it to do error diagnostics after you have an error, so that if something goes wrong, you can say, hey, there was an error, but it's probably because the database or the network went offline, or even before you start executing, you can do that. And then obviously Cypher script if you want to create indexes, call store procedures, those kind of things. You can do that in that script. And in the last minute, I want to talk a little bit as an introduction to Bart's section of the presentation. Is we've started to write everything that Hop does, all the workflows, pipelines, and their components. They're logging now. You can have them log into Neo4j so that you can have a clear graph of the complete execution lineage, along with some metadata actually, so that you know, like, okay, there was an execution of a certain workflow at this given time, and this was the file that executed it. We created a whole new perspective in Hop to do it. So Hop is very easy to create new graphical user interface plugins. And so we created a new perspective which allows you to browse all the past executions, filter on them, and you can see which ones have an error. You can see the logging, and then you can jump straight into the execution lineage, basically, and Neo4j calculates a path. So even if you have a path where you have an error 20 layers deep into a very complex workflow, Neo4j can take a millisecond to figure out, okay, this is the shortest path between the top level job and the lowest execution node with an error and without children. That's a very, very typical shortest path graph algorithm. It means that we can jump straight to the cause of errors in these complicated workflows. And not only that, we can show you which Cypher queries. Harman explained to you that Neo4j has a powerful query language called Cypher, and you can see which queries were used so that you can pop them into your graph browser, and visualize the execution paths, which files were involved, how did these things happen. Last but not least, we can then get also logging information using a new transform. so that we can do calculations of deltas for change data capture, for example, right? Well, if you want to join us with the Apache Hop community, please jump on the hopapache.org, join our Mattermost chat server, and there's a Neo4j channel there for your specific questions as well. So yeah, thank you very much. And I think now it's time for parts.
Well, we had a quick introduction of Neo4j and Apache Hop. Now let's see how we can combine the two with data lineage using Apache Hop on Neo4j. So we'll have a quick introduction, have a look at what data lineage is, the use case, and the data model that we'll use, and then have a quick walkthrough of how we set this up with Hop on Neo4j. First, quick word about who we are as an OBI. We have been a team of, data geeks since early 2012. We're about 200 million seconds old now as a company. And we have our focus is on providing solutions through a number of technologies that we excel in. The focus is not the technology; it's the solutions. But we want to have hands-on expertise in the technologies that we use. We have a background in Pentaho that has gone into more or less maintenance mode, and we're shifting our focus towards Hop now. Another area of focus is Neo4j. We have been a partner since 2016, and we have a strong focus on Neo4j next to Apache Hop that we co-founded late last year, and we have been actively working with our community. Hop is something that we are very passionate about, and some other technologies that we use are Vertica, Column Store, AWS, and increasingly Google Cloud as well. So data lineage, the goal of Lineage is to track your data as it flows through your organization. So as your data flows through systems, is moved from one server to another, you want to keep track of what is happening to all of your data sets, individual data points. With that information in place, with the flow of your information in place, it becomes easier to track issues, for example, to have a look at data quality issues and to perform impact analysis. For example, if you check a column in a source database, you can follow the path of that data and see where it ends up in your data warehouse, which reports, which dashboards are used on that data, and which users would be impacted if you change any of the source data. So that's a very important aspect of your lineage as well. And again, with all of your lineage information in place, it becomes easier to extract that information for compliance and audit reports. And we'll have a look at the data governance operating model. I borrowed this from Colibra, but it applies to Lineage as well. Three main items that we'll look at is structure. So what happens to your data? Where does it happen? Execution and monitoring. So how is your data used? When are changes to your data applied? And in your organization, you want to know who is modifying your data, who is working with your data. And we'll have a look at those three or these five items: what, where, how, when, and who later on. So why Neo4j for data lineage? Well, obviously, Lineage is about the flows of data between states, between systems. You want to have a look at your changes that occur to your data. When is your data merged? Where do you apply lookups, enrich your information? So it's all about the relationships between data at one state, at one stage, on one system, and the flow, the changes of your data from one point to another. Why Apache Hop? Well, Hop was built to do metadata-based data processing. That is what Hop really excels at. And we can do that in both batch, micro-batch, and streaming modes, combinations of batch and streaming. We have, as Matt mentioned, native Neo4j integration that has gotten really rich over the last couple of years. And with the move of Hop to the Apache Software Foundation, we have well, a fully open source platform that we have control over. So we have control over the roadmap. We can add Lineage functionality as we go. So we have full control over a Lineage lifecycle with Neo4j and Apache Hop. Now, these relationships are important. If you look at how the Lineage would have been set up in a relational model, you would need to have, for every stage, for every step in your process, you would need to have a table with a fixed structure. The tables in that schema would need primary foreign key combinations that you would write joins on top of. So you would need tens, hundreds of tables with complex joins that need to be predefined for every question that you want to answer. In the relational world, on the other hand, the schema is a lot more straightforward. You don't have the schema, the fixed database schema, so the schema less structure of your Neo4j graph database allows you to only use the properties that you have available. The conceptual model, as Herman explained, can be a lot simpler on your Lineage database schema. And as far as querying is concerned, you don't need to have all of your predefined queries available. You can use pathfinding and other algorithms to find all the relationships that exist between a couple of nodes or data points that you're interested in. And you can find known or even unknown relationships between those data points. So you have a lot more flexibility there. So what it basically comes down to is choosing either the blue pill, the relational world that we all have a background in, the relational database world that we all have a background in, or the graph world with all its flexibility, as we'll have a look at in a moment. So the use case that we have now is, well, we created a graph of our Hop community. As Matt explained, we have a very active community. We have a lot of our communication on a Mattermost server. Mattermost is our chat channel that is very similar to Slack, and we host that on AWS infrastructure. In that chat channel, in the chat server, we have a couple of teams. We have channels within a team, and obviously users post messages in those channels. Since we are discussing the development of a platform there, we also have a Jira system hosted by the Apache Software Foundation. These issues, bug tickets, or feature requests all have a status, have impacted components, and a lot of these Jira tickets are mentioned throughout the chat messages that we exchange. So what we'll have a look at is how this community graph is built, what the Hop workflows and pipelines are that we use to load that information, what the AWS infrastructure is that we host that Hop server on, and we'll have a look at the auditing, logging, the Git, the Git commit history of the changes that we made there. And we'll have a quick look at who does these changes. We have user information on Git commits, on Jira messages, and of course the messages themselves. So if we'll have a quick look at that in a minute, but the data model that we have for the data is the Mattermost teams. The teams all have a number of channels. The channels have posts created by users. Each post is part of a sequence of posts, and these posts can mention Jira issues, and each of these Jira issues has one or more components and has a status whether a ticket is open, closed, resolved. The lineage model that we'll have a look at is a bit more complex, but still fairly fairly simple. We have a couple of areas that we'll look at. First of all, we have the AWS infrastructure that is logged. We have the actions and transforms. If you come from the Pentaho world, the Kettle world, these are similar to your job entries and steps. We have the workflows and pipelines that these actions and transforms are a part of. Again, if you come from the Kettle world, the workflows and pipelines are similar to your jobs and transformations. We have Git information, so who committed what on which branch. And finally, we have auditing and logging information. So let's dive into the into how this was built. In our Hop GUI, we have a first project, so we'll have a look at the community first. This is how we load the information into our graph. We have the Mattermost, that is workflow Jira, and then we create the relationships between the Mattermost and Jira information. So the Mattermost job first, or workflow first loads what gets an auth token, then uses that to get the teams, gets the users, gets the channels, gets the posts, and creates the posts relationships between your teams, channels, and posts. So, for example, the nodes are a REST request, then JSON parsing, some more detailed JSON parsing, and then we create nodes for components, for statuses, first relationship, and then finally, with a combination of a couple of Cypher queries, we link the last parts of the graph together. If we jump to the Lineage project, and as Matt mentioned, this is something that we have been working on quite hard for Hop to make this as easy as possible to switch between different environments, different projects. So we are now in the Lineage project where you, through configuration, can specify whether you want to load your database information, ETL, AWS, Git logs. We have a module that loads your Pentaho report and Cube information as well. And if we dive into the ETL, first we create the structure of your workflow and pipelines. We load the VPC availability zones, subnets, EC2 instances, and then the relationships for the AWS part. Same for the Git information. And well, the structure is similar to what we saw in the community ETL project. So we have the ETL, well, the workflow and pipeline code that is parsed. We do a lookup to the graph that we have, and then load nodes and relationships to our Neo4j graph. And if we run this pipeline, I already have it preloaded to my Neo4j database. But if we run this, we have the option to create a local runtime configuration. So run this workflow on your local machine, run it on a remote machine, but through Apache Beam. We can also run pipelines on Spark, Flink, and Google Dataflow. So let's jump to the data now. We'll have a quick look at what the data looks like. So in the Mattermost information, we have a number of channels, a number of users. We have 123 active users now, close to 24,000 posts, about 800 issues. The number of users per channel is listed here. Most active users are Matt, Hans, who will show up later, myself, and the rest of the community. And if we have a look at what the actual graph looks like, we have the Hop team, we have the dev channel, which is one of our most active channels, and the one of the issues that was mentioned here is Hop 2114, which is an issue that we had with delete, but has been fixed by now, so it has a status and a component that is linked to it. Could be one or more components. Now we have a sequence of messages where this item was discussed. So it has also been discussed in the beginners channel. There have been a couple of additional messages where this issue was mentioned. And Matt talked about it, so did Hans. Okay, so we have a bit of communication about that issue. And this is the flow of the information that we have. Now, let's see what we can find about the whole process of loading this data into our lineage graph. First, let's have a look at what the structure of our data looks like. So in this first example, I have a quick query that checks a workflow to a pipeline, and we go two relationships deep, either for a workflow or starts. So we have the workflows that link to pipelines through the actions that start them. So we have the same overview for four workflows in our project. Now let's have a look at when these modifications have been done. In this case, we have a query that shows the commits and the related file types. So we have a number of commits on December the 9th, yesterday, for 4 pipelines and 1 workflow. The same information can be returned in a tabular format. So the nature of and the power of storing this lineage information is the graph database, but that doesn't always necessarily mean that your result is a graph. You can have a powerful graph queries that return tabular results. Now let's have a look at execution. So this graph shows that a number of pipelines, number of workflows with the execution results that have been that are linked to it, and we could dive deeper into the audit graph that Matt just mentioned. Now, another thing we want to look at is how is my data modified. So in this case, we have a sort transform. A sort is a very important transform that you sometimes need to produce correct results that may have an impact on performance. So we want to look at what the sorts are that we have in our entire system. We have a couple of workflows, pipelines here, but we have these commit nodes in the graph as well. So let's filter those out. And with this graph, or this query that is a bit more cleaned up now, we get the same sort rows transform type that is used in 2 workflows. So without specifying the exact path of the query, we go from the workflow to the sort rows transform type, and we find all of the actions, pipelines, and individual transforms where we have an impact of this sort rows transform type. Then let's have a look at, let's say we mentioned the AWS infrastructure. I want to find out what where all of the actions are that happen on a region and an EC2 instance in my AWS infrastructure. If I specify the region, I want to look at the AWS regions, and I want to find out which workflows make use of a or make use of my AWS infrastructure. Then I can use the shortest path algorithm to start from a region in AWS, go to a workflow, and I find all of the nodes in between. So this is what I mentioned earlier. We have a region and a workflow, and we don't know every item of the, every work item, every workflow transform that is used there, but we just can traverse the graph and find all of the connected nodes. And then finally, we want to find out who modified the information in our system. So again, we use a shortest path algorithm to find all of the users who have worked on workflows or pipelines that use AWS infrastructure, so our EC2 instance in this case. And with this query, we find that there have been a number of commits made by Hans and myself, and we have 6-7 commits here that impact 4 pipelines. So it becomes very easy to find the workflows and pipelines that we have to be careful when modifying any of our AWS infrastructure. And that's in a nutshell, this is the quick overview of how you can use Neo4j and Apache Hop to build a Lineage framework. We'll extend on the functionality, but this is already, we have quite a bit of information about our system, about the Lineage in our graph here.